A pleasant afternoon, everyone. By the way, we are going to discuss about energy and chemistry, which is one of the topics for the finals. Okay, so I will be having the different topics, which will be the coverage of finals in our GC. So let us start with energy and chemistry. So, by the way, if you talk about energy in physics, we already know that it is being defined as this is the capacity of doing work, or this is the quantitative measure of the uh, quantitative measure of an object, no, which is applied to an object in order to execute into work. And in your high school, you already know that there are different forms of energy. So one of this is bioenergy. Can you still remember what is bioenergy? Later on, as we delve into deeper, sorry for that, deeper types of energy, we will find it out that there are different forms of energy. One of the application of this is known as bioenergy. So this bioenergy actually is coming from an energy which is coming from a plant source, and this will be converted into a biomass. So one of this example of this is we already know that the byproduct, if you're going to squeeze in the industry of sugar making, what happened is the main product of squeezing the sugar cane is molasses. So molasses now is in the form of sugar. It could either be white, brown, okay, and it could either be in a form of molasses. Okay, so but what happened is there is a byproduct of that sugar cane katong wala ma-convert into into a solid form, which is in a liquid form. So that liquid form is now converted into ethanol by means of fermentation. And we already know that ethanol is one of the alternative way of converting it into gasoline, and that is known as bioethanol. So most of our fuel, in order to have it lesser, lesser in its production, what happened is there is an addition of that bioethanol. So possibly the maximum is 30% of that. 20 to 30% of that fuel, the gasoline, are being added on with this bioethanol. Okay, so this is easy. No? This is a kind of a fuel which is known as a renewable fuel. Okay, so unlike with the gasoline, gasoline with the diesel, which is extracted underneath, underneath the earth, and this is very abundant in the OPEC, that is oil petroleum exporting countries, Middle East. What will happen later on is many years from now, this might be exhausted. Mahurot ni siya. So that is why we need to go back to bioethanol. So there are researches already which converts this biodiesel, okay, in a form of that diesel into a biodiesel. For instance, jet trupa. So jet trupa is what's that? Jet trupa is known as tawa-tawa ba na siya? Yeah. So what happened is it is being squeezed, tuba-tuba, not tawa-tawa, tuba-tuba I mean. So that is being squeezed, and what happened is that liquid form after squeezing the tuba-tuba could be converted into a biodiesel. Okay, so that is a form of bioenergy. One thing also of a form of renewable energy is known as wind energy. This kind of an energy does not have any kind of hazard, no? So the wind there, but this could only be applicable if and when that location or that place has a very strong wind. Okay, so we have in Pagudpud, that's Pagudpud, Ilocos Norte. We have windmill, that's known as windmill. Those windmill will convert that into a chemical energy, and that chemical energy will be stored, and later on that will be distributed to the different residents or factories in a form of different energy. We'll find it out later on, no? How it is being converted. So wind farms are one of the alternative energy technologies which later on, no, people, even countries, especially countries, improved countries, will be using it. Why? Because this kind of an energy is no, there is no pollution that will be produced. Okay, so that's it. Another form of energy is batteries. So batteries are now these are chemical cell, na, wherein power is being stored in this device, the batteries. Before, batteries that we know are the batteries which is every battery katong naa sa cell kay ana, but now di na, because that battery could be used in cell phones, no? Cell phones like that, even in some portable gadgets. And that is another form of energy, battery. So in this chapter, we are going to discuss about energy in its connotation, or its, what to call this, its energy, and what is its connection with chemistry. Okay, so we are going to define energy. We will look into the different forms of energy and how it is being transformed and how it is being conserved, and what are the ways of in the laboratory, especially how are we going to know the ways and means of converting this energy into heat, and that is heat capacity and calorimetry. What are the different forms of energy pagyod? That is the enthalpy, and what does it mean by this Hess law? So Hess law will mean heat of reaction. So how are we going to compute this? And the last one is the energy and stoichiometry. So we are going to stoichiometry is the one that we have discussed about the mass, the mole relationship. Then we are going to apply that in energy. Okay, so if we talk about chemistry, that has something to do with heat energy, associated with heat energy, and that is known as thermochemistry. So this has something to do with heat energy, which is associated with chemical reaction, which later on that will be transformed in a physical form. Okay, so that is what we are going to look into, especially there are problem solving here. So as I have said, there are two types of fuel, the renewable and the non-renewable. So all of the fuel which is being extracted underneath and which being processed by countries in the Middle East are non-renewable. Later on, that will be mahurot na siya. Ma'am, ang sun. Oh yeah, sun is non-renewable. No? Also, the biodiesel, no? The one which is being extracted underneath by people in the Middle East are non-renewable. No? Renewable, as I have said, we can have the biomass, okay, no? The biofuel. Okay. So that is how it is being, no? Termed of heat associated with chemical reaction, and that is thermochemistry. Okay, so let us now define energy. So what is energy, by the way? So according to physics, permanente yun ninyo madumduman ni, it is the ability to do work. Okay, so once energy is being, once work, no, once you work, no, what happened is its product, it needs an energy in order to work. No? So that is why we need fuel. For human beings, of course, we need to eat in order that we can sustain in moving or in working. Okay, so that we can produce energy. So energy is taken from what? From the food intake that we have. No? And this is being produced if we are going to walk, if we are going to work, no, like that. And that is what is energy. It is the capacity of doing something. Okay. The general form of energy is being based into two types. That is the kinetic, from the word canon, meaning move. Okay. Then potential, meaning it is stored. No? So if you talk about kinetic energy, this is the energy which, no, has something to do with the movement of energy, no? Associated, of course, of the moving body. And it has a formula of kinetic energy is equal to 1/2 mass multiplied by velocity squared. Okay, so later na ta, magtanaw, what are the units of this? Basta if we talk about energy, this is the most basic form, kinetic and potential. How about potential? So potential has a general, no, formula of, that is Ke for kinetic energy, that Pe, not physical education, but potential energy is equal to the mass. Nagya po yung mass times gravity and height. Okay, so an example of kinetic energy here is when this girl is sitting in the seesaw. Okay, so once she exert, no, once she exert a force, what happened is it will move. The seesaw will move. Okay, so the force which is exerted here will be converted. It will be in a form of kinetic energy. Of course, kung walay mass, di yun na mo lihok ang seesaw. No? So, paglabyog, pabalik, that is what? Velocity. Kung sa kakusgon, labyog, pabalik, o padulong. Okay, vice versa. That is kinetic energy. No? For potential energy, an example for this is, no, this is a car which is moving on the top of a hill. Okay, so the car has a mass. There is a pull of gravity. Okay, and as you look into it, naa siya'y certain height or distance, and that is potential energy. So in kinetic energy, this will be, no, this will be chopped into different types of energy again. Okay, we have 5 here. Okay, another, no, another under kinetic energy. What are these types of energy? The first one is radiant, from the word radiant, meaning this comes from the radiation. Oh, radiant, mom, from the sun. Yes. Okay. We already know in our previous topic about electromagnetic radiation. Okay. So associated with light. So all of those, no, associated with electromagnetic radiation is under radiant energy. Okay. Of course, the glaring or the sun, no? the sun's no? the sun's way of giving off its energy is in a form of radiant. Then thermal. If you talk about thermal, it has something to do with the rise of temperature. No? So, kung mag-boil kag tubig, no? It started with, of course, with a temperature of 0 degrees. No? Then later on, once it will start to, no? to produce bubbles, of course, there is already, it has already a manifestation of an increase in temperature. No? So that kind of uh, that kind of kinetic energy is thermal. And how are we going to compute it later on? The next one is sound. So sound is produced when object vibrates. So while I'm talking here, what happened is the sound waves vibrates, and that is what will be interpreted in your brain as sound. Okay, and that is sound energy under kinetic energy. Another no, type of kinetic energy is mechanical, associated with movement. No? Kining mechanical, of course, is associated also with machines. Okay, moving object using machines. Then the last one is electrical energy. No? So electrical energy is the result of the moving charge of electrons. No? So that these are the different types of energy under kinetic energy. How about potential energy? We have four here. No? The first one is chemical energy. No? The batteries that we have is in a form of chemical energy. So energy stored in the bonds of chemical compounds. That is chemical energy. The next one is gravitational energy, which is associated with gravitational field. Okay, no? So this is one form. Then the third type of potential energy is nuclear. Okay, if you talk about nuclear, of course, it has something to do with these two no, subatomic particles. That's the proton and the neutrons, which reside, of course, in the atomic nuclei. Okay, the most powerful form of energy is nuclear. Yeah, no, which could kill lives. No? Especially nowadays, no, where in Palestine and Israel are having a warfare, and oh my goodness, they are using nuclear weapon. No, nuclear weapon if in a form of what? In a form of rockets. No, so guba-guba ba lang ilang mga houses in Baghdad. Okay. That's nuclear. Then the last one is elastic. It has something to do with meaning. What do you mean by elastic? Meaning it could be it could be stretched out. Once it will be stretched out, what will happen? Of course, this object will be deformed. No? So energy stored as a result of the formation of elastic object, such as stretching of a spring, and that is elastic. Okay. Another form of energy, which is not under potential and kinetic, is the heat and work. Na? So we already know the product of energy. No? So all energy flows either heat or work. Heat, what is heat? Heat is the measure of the coldness and the hotness of the body. What's work? Work, of course, is manifested when there is a force exerted in with a certain distance. Okay, no? So heat has, this is heat. Heat has, heat is being, the one we use for heat is Q, small letter Q. No? So heat is the flow of thermal energy between two objects. So if there is heat, of course, there is a change in the temperature. Nag-initial na ay final temperature. Kaya nga naman, there is an energy, a thermal energy that flow between one object with another object. No? From the warmer one to the cooler one because of their difference in the temperature. Okay. So the one that passes, the one that passes with that flow of thermal energy is now known as the process. It's not a quantity. May kag quantity, may kag daghan dili. No. Ang iyang procedure, ang iyang pag-transform from from one temperature pag-flow, pag-flow sa energy, thermal energy, and that is process. Process could either be reversible and irreversible. Reversible meaning mabalik pa nimo, no? Irreversible dili na gyud mabalik. Okay, no? So that is heat. Then another form of energy, which is the transformation of energy, is work. So work is the transfer of energy. This is accomplished by a force moving a mass at a distance against the resistance. Can you still remember what is the formula of work in your physics? Work is equal to force times, huh? That is, work is equal to force times distance. Okay, that is work. That is why you have here force accomplished by force moving a mass with some distance. Okay, so that is the manifestation of energy. Huh? And if you talk about work, huh, there are several things that we should know about it. Huh? The first one is the work which is associated with pressure and volume. Okay, so associated with pressure and volume, and that is pressure volume work. That is PV work. Yeah? So this is the most common, which is encountered in the chemical transformation or chemical process. So especially when gas expands, it can do work. An example of this is the burning of gasoline in the car engine. How your fuel is being converted into the turbines. The turbines sa iyang what do you call this? Sa makina sa sa car, no? How pag tubil, of course, what will happen? Di ka na mudagan kung wait gasolina, no? So how it is being converted into work? Of course, if you look into this is now the formula. The C8H18. What is C8? This is octane. Na? Octane by means of combustion. May combustion na burning. Na? By means of combustion, what happened? There is a presence of oxygen. You will produce carbon dioxide and water. Carbon dioxide and water. That is why in the steam engine, sa imong turbine, sa uh, car, magtuyok-tuyok ra gyud pud na ang tubig, Okay. Why? Because this is what happened with the fuel that you have. The octane with the presence of oxygen in the air that will be converted into carbon dioxide and water. So the gas produced in the above chemical reaction will do a PV work, pressure volume. So mo na ni mahitabo mo expand ang imong piston sa imong what you call this, sa imong engine sa imong car, and this will make your car move. Okay, so these are the different units in energy. The SI unit that we are using is the joule, which is abbreviated by J, and this is being discovered by James Prescott Joule. So, in 1 joule, 1 joule that is equal to 1 Newton meter. Tas kaning Newton meter is equal to joule. No? What is Newton? So may Newton. Newton is the unit of force, di ba? This is work. No? Work is or energy, work lang. No? Work is equal to force. Ang force, the unit of force is Newton. Multiply by distance, you will have joule. No? What is Newton? Newton. No? Newton is equal to the force. No? And it has a formula of or a unit of kilogram meter Newton. No? That's kilogram meter squared per second squared. And that is 1 Newton. No? I hope you can still remember your physics with you. No? So in 1 joule, that is equivalent to 1 Newton meter, no? Or 1 kilogram meter squared per second squared. No? That is in 1 joule. In 1 kilojoule, that is 1,000 joule. No? But in terms of food, okay, in terms of heat, especially heat, no? We are using calorie, not joule. So work, we are using this unit joule. But if you are using no, heat or heat and the food intake, we are using calorie. Okay. So in 1 calorie, that is equivalent to 4.184 joule. Be sure that you should memorize this. No? So in 1 calorie, no, that is equivalent to 4.1. This is not a 4,000. Sayop ni siya. That is 4.184 joule. So this is used in food. Most of those who are dieting, they are very particular with the calorie intake that they have. The more calorie intake that you will have, the more what will happen? Of course, this will be converted into the stored energy, and this has something to stored food in our system, and this will cause somebody to gain weight, especially kanang mga pagkaon nga puno og carbo, that is carbo loading. Hilig ra pagyud mo ana nga mukaon og pansit, pansit tapos napagyoy kanon. No? Ang pansit, the noodle itself is in a form of carbohydrates. Then the rice is still in a form of carbohydrates. That's carbo loading. Good kung dili kain mo tambok. Okay, because you need more energy. Oh, mom, we need energy. Yes. How about if you're gonna use that out? Okay ra og mag-work out mo. Yeah. So the food intake that you have, you will exert it out of your system, out of your body in a form of exercise. That could be. Okay. Pero kung may trabaho on, magsige na mong ingkod, oh my goodness. That should not be. What will happen? That will be converted to adipose tissue. Okay, or stored fat. Another unit of this, so natay joule, natay calorie. That's the unit. Now, as I have said, joule, mostly this is being used in, what they call this, being used in application of work. This calorie is in application of heat or in the food intake. Then we have the BTU. What's BTU? That is the British Thermal Unit. This is an old unit, the BTU. No? The English system. Okay. What is its equivalent in joule? That is 1,550 joule. Or, but if it will be related to work, PV work, pressure volume work, we will be using a unit of liter atmosphere. In 1 liter atmosphere, that is equivalent to how many joule? 101.3 joule. Of course, I expect that you are going to memorize this unit. The different conversion of unit in joule to kilojoule, calorie into joule, BTU, British thermal unit into joule, and liter atmosphere into joule. No? So how is it? No? How it is being done? No? How energy is being used? No? Of course, this is being used by means of its transformation. No? If you talk about transformation, no, kung transformation is meaning from na, an old one to a new one, from old product to a new product. Okay, from old energy, na, from one energy to another energy. Na? That is energy transformation. An example for this is na, the one na, in Iligan, the Maria Cristina Falls, wherein we used to, this is the main source of the hydroelectric power plant, na, wherein we had our electricity. How? Okay. So, Maria Cristina falls na siya. Okay. Di na siya true. Falls na siya. Okay. So, what happened is, no, because of the swiftness of the current in the falls, no, so, kusog paghagbong sa tubig sa Maria Cristina Falls, of course, it will go down, no? Pag go down niya, laom kay nga na part, no? So, because of the swiftness, they have it on their mind that this could be transformed into another form of energy. So, from kinetic energy, what they did is they placed big turbines or big dynamo. Usa man ang dynamo, ma'am? Okay. Mura na siya mga bicycle, bita ka na, bisikleta or na, na ay nga magtuyok, no? So dagko kayo, pila ka dagko, mga 2 story, basta dagko kayo na siya nga turbines gibutangan to. But because of the swiftness of the current, what happened? Of course, this will no? This will move, no? This will move because of the swiftness of the current. So from electrical energy, they place in, no? No, in the hydro is water, hydroelectrical power plant, tawag na. That big dynamo, which is in a mechanical energy, so no, from kinetic energy, then mechanical energy, then this will be converted into chemical energy, meaning store ni sa ilang storing plant in a form of chemical energy. Then later on, once we need electricity, so this will be, no, this is being distributed to the different houses, to the different factories, no, the one that will be using electrical energy. No? So electrical energy na pag ana itong suga, naanay suga. Mao na, no? Tapos gusto pud ta og bugnaw, electric fan, that's heat energy. Gusto pud ta magluto, it's heat energy. So see what happened to that energy? The first source of energy is the kinetic energy. It is converted into mechanical energy. It is converted again into electrical energy, chemical energy. Then it's stored, then distributed to the different houses or residences or factories in a form of electrical energy. Pag abot sa balay, mamalansa, heat energy, so on and so forth. Okay, see? Okay, so what does it mean by this? No? So energy is just being transformed. So energy, the first law of energy, no? The first law of conservation of energy states that energy cannot be created nor be destroyed, but it will only be transformed into another form. No? Is there anybody nga makahimog energy? No. No? It could not be created. Di ko na siya ma-destroy. Pero pwede nimo siya ma-convert into different forms. Okay, that's it. So, we have a cell here, a battery cell kani, sa flashlight. Okay. So, what happened? So, naa siya chemical energy. Anong chemical energy mo? Diba, naaman na siya positive o negative charge. Okay, pag ana nimo ka di ba naamang kana sa cell na sa battery cell na ana siya positive and negative charge. So kung nagay positive and negative charge na kuan sa imong wires, what will happen? Of course, these electrons will what? Flow. Okay. So battery, which is a form of chemical energy, then we have wires here. No? Mga mo flow, it is now electrical energy. Then an output of that is light. So light and heat energy. No? Light and heat energy. See? No? From the chemical energy, it is converted into electrical energy, then into light and heat energy. Okay. So in the energy transformation, no, this applies no, the law when one form of energy, kato kong example ganina, it is a kinetic energy, katong flow sa inyong sa Maria Cristina Falls. Okay, that is one type of energy, one form of energy, which convert later on into different form of energy. Okay, so the first law of energy is that the total energy must be conserved, or the total amount of energy must be constant. No? And there are terms that is being used here. No? You should know this. First is the system. What do you mean by system? This is part of the universe that is being considered. That is system. No? Second is the surroundings, meaning the remainder of the universe. System plus surrounding is the universe. The total, the sum total is the universe. And the one that separates your surrounding from your system is known as the boundary. Pila ka buok? Upat ka buok. System, surroundings, and universe, and boundary. So these are the terms that is being used in the conservation, in the energy, no? In the study of energy. No? So in the transformation, you should be careful in, no, in defining which is the system and the surrounding. System can, for instance, can hot water. This is a glass, then you place in hot water. Kana nga na sulod nga is the system. Ha? Kana sulod sa glass is the system. Ang gawas sa glass is the surrounding. No? If you are going to hold on the glass with hot water, of course, that is now the energy. There is a transfer of energy of the molecule. Una pa, kaning glass, bugnaw pa ni, pero pagbutang ni mong init tubig, what happened? There is a transfer of energy. So what happened? There is from hot to cold, or cold to hot. Ana na siya. So, importante that you should know, you should identify what is system and what is surrounding. Okay. One thing that is very important in energy and heat is, of course, we should define what is heat and temperature. If you talk about heat, of course, this is the measure of the hotness and coldness of the body. Or this is known as the transfer of thermal energy between two bodies at a different temperature. Na by transferring same ang temperature, daily, it should be different. So if you have hot water, okay, in hot water in a cup, pagbutang nimo sa imong teaspoon or kutsara, later on pagkuha nimo, init na. Of course, there is already a transfer of molecules, katong init padulong sa imong kutsara, from hot to cold. Kutsara nimo cold. Later on, it will have an increase in temperature, and that is known as heat. Temperature is the measure of the thermal energy. Measure na siya. Heat is the transfer, ha? Ang heat is the transfer, while temperature is the measure. And we already know that there are how many? No? How many temperature scale? We have the centigrade, the Fahrenheit, and the Kelvin. But we are always using the absolute. The absolute is the Kelvin. That is 273, whatever is the temperature in centigrade. So that 273.15 is constant. So here is an example of this one. Kato, kani siya is ang tasa is ang sukuan ani is heat. Makita nimo nga mo mag-aso-aso siya. Why? Because there is already a transfer of thermal energy. Later on, pag kuan mo sa thermometer ani, di na siya init, bugnaw na siya. Kanipod. Okay. Sa shower, what happened? Ang imong, that is why we need to take a bath. Nga naman, grabe kaigang. So our body temperature needs to lower down. Okay. So once we had this shower, what will happen? Our body temperature cools off. Okay, muubos. And that is a heat transfer, a kind of heat transfer. The lowering of your temperature, lowering of your thermal energy in your body is known as the temperature. So here, we have different types of system. The open, closed, isolated. Now, open, closed, and isolated. How could you differentiate this one? Through their exchange. So, in an open system, what happened? Na ay mass and energy. Okay, so if this is, you add on a hot water here, what happened? Of course, there is a mixing of your heat here. Your heat, gani aden, mo paghawi di mo sa bottle, wa na, init na. Ang uban ana mo gawas ganis ibabaw. Okay, that is an open system. Ang closed system is pagbutang nimo sa pagbutang nimo sa what you call this, pagbutang nimo sa hot water, takloban dayon. Pag taklob, of course, walay di siya kagawas nga niya. Maghulat lang nga there will be a transfer of heat here. The heat here kani walay laing kautlot sanad. The one isolated is in a vacuum. Meaning dili siya kagawas ang heat niya. There will be no heat transfer. So what kind of system is that? That is an open system, meaning na ay other kalutsan. Then the closed, dili siya kagawas. Ang isolated, it's in a vacuum. Okay? So in the conservation of energy, we already know that it will only be converted. Heat, energy, will only be converted. The energy that we have will only be converted into another form. It will not be destroyed. It will not be created, but it will only be transformed into another form. So the overall change in energy, which is abbreviated or it has that symbol E of a system, can be expressed in terms of heat and work. So that is the change in energy or internal energy is equal to Q plus W. What is Q? That's heat. What is W? Work. So that's equation 1. So if you have a system wherein it has two ways or two process, what happened is the internal energy will be the energy in the final minus the energy applied initial. That's the conservation of energy. And there are important conventions that you should remember. First thing in heat. Okay. So if system gives heat, kung ang system mo ay mohatag og heat, what happened? Therefore, heat or Q is less than, na? Q is less than 0. So, Q is negative. Na? So, basta system gani gives out heat, your Q is negative. Nga naman because less than 0 ang imong heat. Na? Pero if system gets heat, now meaning it is being applied with heat, it is applied with an increase in temperature, therefore your heat is greater than 0. Therefore, Q is positive. This is in the application of heat. Then, in work, now, if system does work, kung ang system mo oy, no, nag-apply into work, okay, what happened? Work is less than 0, therefore work is negative. Basta dumdumong gani mo ang heat is less than 0, negative. W gani is less than 0, it's negative also. So if work done on the system, what happened? Work is greater than 0, therefore work is positive. Diba? Ang manifestation nato sa energy is heat, diba? Then work and the pressure volume work. So work applied with the negative pressure and the change in volume. This is applicable when applied in expanding of the gas. Okay, that's it. So let us apply now this. Okay, for instance, if 515 joule of heat is added, take a look, added to a gas that does 218 joule of work as a result, what is the change in internal energy or energy in the system? Let us identify first the given. Tanaw nato og tanaw nato siya kung added ba siya or done on the system. So first, heat added, therefore heat is added to the system. What happened? Added man. Added gani meaning dako ang imong Q, it is greater than 0. Basta greater than 0 meaning your Q is positive. Therefore, this 515 nga heat is positive 515 joule. Then, work done by the system. Take a look. That does 218 joule of work as a result. Kita gani kag as a result, meaning work is done by the system. Therefore, your work is what? Less than 0. So, your work here is negative. Halaka. So, you should know the technique in knowing if it is your Q is positive or negative. Same thing with work. So, solving now, we already know that the formula is change in energy. Internal energy is equal to Q, which is the heat, plus work. So that is, substitute now the value of Q, which is 515 joule. Then plus, substitute the value of work, which is negative 218. Subtract this one. Therefore, our work, the internal energy in the system is equal to positive 297 joule. Okay. Another example. Here it is, a sample of nitrogen gas expands in volume from 1.6 liter. This is an application of pressure volume. Pressure volume work. A sample of nitrogen gas expands in volume of 1.6 liter to 5.4 liters. So this is the initial volume. This is the final volume and at constant temperature. Meaning gani kag constant temperature, this will be our formula. So what is the work done on the joule? in joules if the gas expands. No? So our first formula, where work is equal to no, negative pressure multiplied by change in volume. What will be our change in volume? Of course, final minus initial. Now that is 5.4 liters minus 1.6 liters is equal to 3.8. That is our work. Now, but how about if it is no, in a vacuum? Against the vacuum inertia. How about if it has a constant pressure? So what will happen is, if it is constant, may ganing constant mga bata, zero gina siya. Na? Therefore, work minus pressure, then change in volume. What will be our pressure? That is zero. Then our volume, which is 3.8 liters, any number multiplied by zero is zero. Therefore, our work, once it is in the vacuum and at the same time it is constant pressure, it is equal to zero. Okay, now another example here. Now, example 3, a sample of nitrogen gas expands in volume from 1.6 liter to 5.4 liter at constant temperature. Okay, so your initial volume is 1.6 and your final volume is 5.4. Okay, no? So what will be our work no, against the vacuum? Take a look. This work done in joule no, is applied with constant temperature. Therefore, work is equal to negative pressure multiplied by change in volume. So what happened? So here it is. Our work will be equal to no, pressure, no, negative pressure multiplied by change in volume. Okay. The final volume here is equal to 5.4, then minus initial volume, which is 1.6. Therefore, that is equal to 3.8. Okay. Pangayo sa receive. Ay, papirmaha lang. Okay. So, papirmaha. Receive the amount. Okay. At B, what happened? Sorry for the interruption. Therefore, that is B, that is pressure is equal to 3.7 atmosphere. No? Dili siya constant. Na-given yung pressure. Okay. Constant pressure pero it has a given of 3.7. Therefore, work is equal to negative P multiplied by change in volume. Therefore, that is our pressure given is 3.7 times multiplied by the change in volume. That is 3.8. That is equivalent to 14.1 liter atmosphere. And we know we go back to our unit. We already know that in 1 liter atmosphere, that is equivalent to 101.13 joule. So cancel ang liter atmosphere ang nabilin is joule. It's negative. Nga naman kay negative mani ang formula. Negative P multiplied by change in volume. No? So that is now our application of a constant, the heat and work for solving for the energy. So the change in internal energy of the system is precisely offset the change in surroundings. So we can assume that the change in internal energy in the surrounding is equal to the negative internal energy of the system. So energy of the universe remains constant. Therefore, the change in internal energy of the universe is equal to the change in the internal energy of the surroundings plus change in internal energy of the system. No? So the first law of thermodynamics applies now the conservation energy principle. No? It states that energy principle to system where heat transfer doing work are methods of transferring energy into and out of the system. So we have this general formula for the first law of the thermodynamics, that is the change in the internal energy is equal to heat Q plus work W. Always remember that energy is neither created nor be destroyed, but it can only be transformed into another form or into another work. Okay. Take a look here. This our example. This table 9.1 are the efficiency, no, of the conversion of energy using different devices. Okay. Take a look. Electrical heater, the electric heater. Kung electric heater, of course, you have the heater, which is you pansak, no? You plug in, no? So that is electrical, then converted into thermal. Paghawid mo, init na. Na? This is its percentage efficiency. Na? Okay. Hair dryer, meaning kani sila, no? Less than. Na? That is less than 100% efficient. Or almost there, almost 100% efficient. Hair dryer, that is electrical, okay, you are going to plug in, then it will give off heat on your hair. No? Okay. Aroma dry imong buhok. And that is thermal. No? Electric generator, that is generator, meaning it's the machine, no? Converted to electricity. So mechanical to electrical. Na? That's 95% efficient. The steam boiler, especially in the power plant, no? That's chemical to thermal. That's 85. Home gas furnace, then steam turbine, the silicon, the incandescent lamp, no? So these are the different devices which is having this different energy conversion and its total efficiency. Okay. So we are now in heat capacities and calorimetry. No? So since it's pandemic, we could not apply this in the laboratory. No? Calorimeter, no? We have the calorimeter that is in a form of no? Murag cup, na? Cup wherein na ay outer of my inner cup. No? So especially the bomb calorimeter, this could insulate no? The absorption of heat outside its surroundings. No? So the question there is there systematic way to measure energy flow? No? Is there a systematic way to measure energy flow? No? Of course, it could be that it could be done by means of the a technique in the laboratory which is known as the calorimetry. Mabalaan nimo ang change of heat, na? Katong namo guna siya inner cup o outer cup, no? So pag butang nimo og init tubig, what will happen? Or mag init tubig, what will happen is there will be a transfer, no? There will be an transfer of heat from lisod ang transfer of heat, dugay ang transfer of heat kay ngano man insulated man na siya sa ilalom, no? And that is calorimetry. So what are insulated, meaning absorbed siya inside? Okay, so what are this amount of energy that can be absorbed by the system? First, what are these factors? Of course, kung daghanon nimo ang for instance, mo gani kung maligo ka tas tugnaw kaayo, na? Wala kay heater, pag bukal og tubig tapos ibutang siya sa imong tubig nga bugnaw. So, dili kaayo bugnaw ang imong ikaligo. Pero, kung perting daghan na nga tubig, okay, Amount of material, ha? Perting daghan nga tubig ang imong store, then you are going to have only one, no, kanang gamay nga takuri nga nainit tubig. What will happen? Dili kaayo siya init. Ngano man, because the amount of energy absorbed in the system, meaning katong sa imong tubig, is being affected with the amount of material, the amount of your water. Okay. Another one is the type of material. Okay. Wa pa mo ka-observe nga boiling water kung mo splatter sa inyo, dili ka siya sakit. But my goodness, if it is an oil, tinga kasakit kayo nga naman. The boiling of water is only 100 degrees while oil will boil up to 200 kapin. So init yung kayo siya. So these are the factors that affects the absorption of your system. First is the amount. Second is the type of material. Sana siya. And the last one is temperature change. Okay. Meaning from man, taas ba iyang temperature change? Ubos ba kayang initial kontra sa o taas kayang final? Or no, taas yung initial tapos di kayo taas yung final temperature. And those are three factors that affect the amount of energy absorption in the system. Amount of material, the type of material, and the temperature change. Okay. So in the heat capacity, una-unahon na lang na to. Heat could be computed by means of a formula. Q is equal to mc delta T. Okay. Q is the heat, then M is the mass, then C is the specific heat, and delta T is the change in temperature. So what is specific heat? Let us define this. Lahi ang specific heat, lahi ang molar heat. Specific heat, C ratio. It is having abbreviated by C. This one is abbreviated by CP. Okay, no? So, here what happened? Balik ta. Okay. A minute. Let me. Okay. So, what happened here? No? So, your unit for specific heat, di ba ingon ko sa inyo, your heat has a formula. Another formula of heat is equal to mc delta T, where M is the mass, C is the specific heat, and delta T is the change in temperature. What is the unit of specific heat? What is specific heat, by the way? Specific heat is the measure how much heat is required to raise the temperature from 1 gram of that material, or 1 by 1 degree. So 1 material, an increase in 1 degree centigrade. So it has a unit of joule per gram centigrade. How about molar capacity? This is different thing with specific heat because CP, abbreviated as CP, measure how much heat is required to raise the temperature of a mole. That is why it's molar heat. This is specific heat. Molar heat, you have 1 mole. This is 1 gram of material. This is 1 mole of a substance by 1 degree. Therefore, your unit heat here, your molar heat capacity is joule per mole centigrade. Here, because it is specific heat, it has a unit of joule per gram degree centigrade. Here, because it has molar heat capacity, it is joule per mole degree centigrade. No? So, this is now the one that I had said. No? So, considering all these 3 factors, katong tulo ka factor, that is the type of material, now the temperature, okay? Therefore, our formula for heat is equal to mc delta T. M is the mass, C is the specific heat, delta T is the change in temperature. May kang change, that will be final temperature minus initial temperature. But if you will be using the molar heat, that is Q is equal to NCP delta T. So that is N Here is mass. Here is mole. Okay, mole, no? That is 1 mole multiplied by specific. No? This is now the molar heat capacity, and delta T is the change in temperature, that final minus initial. Okay, that is it. Lahi ang Q nga gamit specific heat. Kay ang imong gamiton nga mass is grams. Ang imong gamiton nga ni is mass in terms of gram. If it is a molar heat capacity, of course, molar. You will be using here N, which is the mole, 1 mole. Okay. So be sure to have a copy of this now, because these are constant. These are the specific heat capacities of some substance: aluminum, copper, water. No? Duhaning tuluning water. Tulo biya ka form ang water, that is in solid, in liquid, and gas. So these are its specific heat constant of this. Take a look. Mag-differ ang water in a solid, water in liquid, and water in a gaseous. Lahi pod ang molar capacities. No? So specific heat, you will have a formula, or you will have a unit of joule per gram degree Kelvin. As Kelvin or centigrade, pwede ra pareho siya. That this one for the molar heat capacity is joule per mole degree Kelvin. Okay, example for this. Na? So here it is, heating at 24 grams. Oh, basta makita na grams, that is, bear that in your mind, that is the mass. Aluminum can raises its temperature, no? by 15 degrees centigrade. Meaning, this is already wala na given nga initial. Meaning, raises. Meaning, from final to initial. Iusa na niya, na? Therefore, this is now the what? The change in temperature. You are going to get Q, na? So, or heat. Heat as a formula of, sa ito gamito nga niya? Specific heat or molar heat capacity. It should be specific heat. Therefore, your Q is equal to mc delta T, or mass multiplied by specific heat capacities and change in temperature. So our mass is 24. No? C, take a look. Asa matamo ko anang C? It's aluminum. Okay, aluminum here. So it's 0.9 na joule per gram degree centigrade Kelvin. Okay, here 0.9. So kuha na ninyo where we get this. This is constant for aluminum. That's 0.900 or 0.9 joule per gram centigrade. Then the change in temperature is 15. So what unit can we cancel? Cancel the gram. Okay, cancel the centigrade. What remains is joule, which is the unit of your heat. Okay. Another example, the molar heat capacity, ganina is specific ang gamit. The molar heat capacity of liquid water is 75.3 joule per mole Kelvin. If 37, so what's this? Molar heat capacity. So you will be using C or CP. It is CP. Okay. Then, if 37.5 grams of water is cooled, 37, this is the mass of water. Okay. From 42 degrees centigrade to 7 degrees centigrade. Meaning, this is your initial and this is your final. So, your final will be 7 minus initial 42. So, your temperature, change in temperature will be negative 35 degrees centigrade. Okay? But as I have said, the formula that you are going to use will be Q, not MC delta T, but you will be using NCP delta T. Why? Because we are using the mole here. We are using the molar heat capacities. So how are we going to get the N or the mole? We already know, can you remember, in our stoichiometry, we have The number of moles is equal to the mass multiplied by the molecular weight of water. What's the molecular weight of water? It's 18. Why 18? How many atoms of hydrogen? That is 2. And what is the molar mass of hydrogen? That's 1. So 2 times 1. Then oxygen is having 1 atom. The molar mass is 16. Okay. 2 plus 16, 18. Any more than siya. So 37.5 grams divided by the molar mass ng 18.02 gram per mole. Cancel ang gram, saka ang mole. Therefore, 2.08 mole. So nanatay n nga equivalent to 2.08. Our specific heat constant is what? Given ni siya. Ani, 75.3 joule multiplied by our change in temperature. Finally, why is it that we have negative? Because your temperature is from what? From hot to cold. Cool. No? Cold. No? Gikan init ngadto sa bugnaw. Of course, ang temperature will be negative. Okay. So your heat is equal to negative 5.49 kilojoule. Okay. Another example here. Here is our problem. That is okay. Here it is. That is a glass contains 250 grams of water. 250 grams of warm water. What's the temperature of that warm water? That is 78 degrees centigrade. Then a piece of gold, which has a temperature of 2.3 is placed in the water. So if you have a beaker, for instance, it's a beaker. This beaker has warm water. Then beaker here, the beaker with 250 grams of warm water. What's the temperature of your warm water? The 78. So then, if you have now a rod, kanang, what you call this? Kanang clip, kaning gold, piece of gold is being dipped or being placed in your beaker with warm water. Do you get it? So your gold has a temperature of 2.3. So the final temperature reached by this system is 76.9. Okay. If you look into this, what happened? You have already two bodies. That's the water, and you have your water, and you have your gold. Okay. So you have gold and water. So how are you going to have now your heat? How are you going to compute for your heat? You will have two heat here. The Q total, the heat total will be equal to the heat, the heat by the water plus the heat by the gold. That is it. But your total heat will be equal to 0. So kung mao mahitabo, that is, ang mahitabo dayon ana is the heat of gold is equal to the heat of water. But that will be equal to negative. Kadumdum mo, system? Okay. That is it. So heat is equal to what? Heat of gold is equal to the mass of gold, specific heat of gold, then change in temperature of gold. That is equal to the heat, the mass of water, the heat of water, that is the mass of water, the negative, because it is done on the system. Okay. Negative mass of water multiplied by specific heat of water and the change in temperature in water. So, first thing is we should know the mass. Mass of gold is 2. Mass of gold is, asa mass of gold? Wala, no? Ngong may gipangita, the mass of gold. Pero kabalo ta specific heat sa gold. no? Specific heat of gold is given, that is 0.129 joule. The specific heat of water is also given. What will be the change in temperature of gold? That is, syempre, pag butang nimo sa init tubig, na, ang initial will be, na, initial ani is pagbutang, that is 2.3, no? Then, pag mix na dayon niya, is i-minus nimo ni, that is 78 minus 2.3. How much is it? It is 74.6 because this is the initial, this is the initial, no? This is the final minus the initial. Okay. How about for the water? No? No. Water has, no? What will be the water? No? What will be its water? Its water is final temperature na ni kani, no? This is kaning final temperature is in the system. Meaning from your katong 78 point na 78.0 minus 2.3, that is 74.6. How about your other one? Na? Katong sa imong final temperature niya is katong sa water. So water is, this is your, na, initial, and this is your final. Okay, so final, which is 76.9 minus 78 is negative 1.1 degrees centigrade. So by means of multiply all of this here, no? Then multiply all of this here, no? What will remain is you can cancel or you can transpose it there. Or pwede ka ni i-multiply na ninyo tanan, pwede raman. No? What will remain here is in terms of cancel ang gram, cancel and centigrade, ang nabilin is joule. That is, your product here will be positive. Over by this, no? Multiply this, ang mabilin is ang, no, joule gram, no? Joule per gram. Okay, so divide this, you will have a mass of gold equal to 120 grams. So try to practice it in your own. Okay, so that ends our part 1, and I will be discussing, uploading again our part 2 because this is a little bit, na, dako-dako ni siya coverage. So thank you for listening and have a pleasant day, everyone.